All right. What we have here is we're going to talk about 6.1 day 2, probability and continuous random variables. Um, we know how to find expected value in our previous notes, and now we're talking about standard deviation of a discrete random variable, of a discrete probability distribution. That is, sorry, standard deviation, discrete probability distribution. And so first off, we can find this by finding the variance. Variance, once again, the standard deviation squared. Make sure you know that difference between that. And to find the standard deviation, you take the square root of the variance. And how do you find this? Well, if you take your variable minus the mean expected value, square it, and multiply by the probability of each one of those events, add them all together, take the square root, that's where you find your standard deviation. Now, since we know how to find the mean and the standard deviation, we then can create a normal curve if the distribution of this discrete probability distribution is normal, or this continuous random variable, not discrete, but continuous random variable is normal. We can do it using what we learned in earlier chapters on finding a z-score or using normal CDF to help us determine this. We can also find this by using a uniform area if we happen to have a continuous random variable that's uniform. So to help us out with this, let's go through an example to check our understanding. And so we have the height of a young woman can be modeled by a normal distribution, okay, with a mean of 64 inches and a standard deviation of 2.7 inches. Suppose we choose a woman at random, let y be her height in inches. What type of variable is y discrete? Well, since we're talking about height, height is continuous, all right, because there is no fixed value, all right. Continuous, no fixed values for height. All right, and that's what we know. Now let's find the standard deviation of this. I'm going to change my thing right here. Now to find the standard deviation, our standard deviation is 2. So um, uh, the typical, or the height of a young woman, men, of a young woman uh, randomly selected, typically varies by 2.7 inches from the mean height of 64 inches. That's what we know. And so now this next thing is, let's talk about this. Find the probability that y, her height, will be 63 inches or less. And we're going to interpret this value. And so what we know is, because this is a normal distribution, it is continuous. We can use what we've done in the past. So I'm going to draw this normal curve. And if we have a normal curve right here where we know our mean is 64, and we're trying to do 2.7 right there, well, 63 is right down here at 63. And we're trying to find a value which are going to be greater than that. Okay, greater than that. All right, greater than that. And so what we can do is to find this value is we can use a normal CDF where we have a lower end of 63, and we can see that from our display. We can have a upper, all right, of, I don't know, let's go 1,000. All right, for height, then I'm going to get that all, but let's go 1,000. We'll talk about our mean of y. All right, that is going to be 64. And then we'll have a standard deviation of our y. In this case, it's going to be 2.7. So if you go in our calculators, you can go, once again, the second distribution of bars. We're going to go down to normal CDF. We're going to have 63 is our lower, our upper is going to be 1,000. I'm going to put, all right, put in 10,000, doesn't really matter. 64, and then we'll put in our standard deviation of 2.7. from here, we're going to paste this, and we'll get our answer of, and I'll just simplify this a little bit. All right, of 0.644. All right, we could also find a z-score if we want to find the z-score. Okay, we can take R63 minus R64 divided by 2.7, and if you punch that into your calculator, you'll have a value of, all right, divided by 2.7 of right here of negative 0.370. And so if you were to write this using a table Z or a table A, you have our standard deviation here, it's right there, negative 0.37, and we're finding that area right there. Once again, going through the same thing, and we get our value. So let's interpret this value. So the probability of randomly selecting a woman that is 60. Oh no, I went the wrong way. Oh man, 63, all right, inches or less is, oh my God, my gosh, my golly. All right, this is why we do this all over again. Oh my goodness. If you went to this video, you're probably saying, oh, right here, because the y value has to be less than that. All right, so this is going to change everything. Let's delete all this stuff. All right. All right, and so, oh my goodness. Oops, 64 can stay there. All right, but our different values are going to change. I'm glad. That's why we guess we could go through and do this. All right, so we can see what it is. And so right here, distribution of this one. What are we going to start here? Well, let's go normal distribution. All right, go down. Try this one more time. Let's go negative 1,000. We won't have our negative height. All right, negative 10,000. We'll go, this one's going to be 63. And then we'll just keep on going down right here. And let's find out what it's going to be. All right, now we finally found our answer right there. Sorry about that. If you probably caught that already. And so what we have is negative 1,000. Probably could put 0 in there. And we have 63 is going to be our upper. And that's going to change our value, which is going to be 0.356, which is 0.356. So the probability of random selecting a woman that is 0.356. All right. From here, we can do something very, very similar. And now what we're going to do is go through the same process. We're going to have our 64, 2.7, and we want to figure out, okay, 64. Where is 68? 68 is going to be right there. Go up to 70, which is right there. And we're trying to find out what is the value between them. Okay, that's shaded region right there. So once again, we can find out the probability of randomly selecting a woman, which is going to have a height between, selecting a woman with a height that is, all right, right there. And so we can go normal, CDF, and we can go lower, which appears to be 68. Go upper, which is 70. We're going to have the same mean, which in this case is 64. And then we're going to have a standard deviation right here of 2.7. All right, 2.7. And so if we go on our calculator again, normal CDF. You should be doing this pretty fast now. I apologize for the length of this video. 68, because you probably already got all this stuff down. You probably haven't hearing this last part. Am I right? Am I right? All right, all right. All right. And then I go over here and bada bing, bada boom. And I'll take this value right there. And our value that we're looking for now, all right, is that one. And we found this value to be 0.056. So what do we find? The probability of randomly selecting a woman with a height between 68 and 70 inches is I'm going to say about 0.056. Bomb, boom, nailed it. All right, and that's what we know there. All right, so using normal distribution, okay, and a continuous random variable, we can find standard deviations, we can find probabilities, especially when we have a normal distribution using what we know as normal CDF or z-score, however we want to continue. All right, we'll go. Good luck and God bless the rest of your problems.